Hey, and welcome to this lesson on corresponding angles. In this lesson, we'll answer the essential questions. What are congruent angles? What are vertical angles? What are corresponding angles? By the end of the lesson, you should be able to understand the relationship of intersecting lines. We've discussed this before, but it's okay for a little review. Angles that have the exact same measure are congruent angles. No matter how they're situated, turned or flipped or rotated or mirrored, if they have the same measure, they are congruent angles. All right, we talked in the previous lesson about when two lines meet, they make four angles. Well, when two lines meet, the angles opposite each other are called vertical angles. Now, we've talked about them before. They're the angles opposite each other. So, in this figure, A and D are vertical angles, and angles B and C are vertical angles. First actual theorem we're going to talk about in this class is the vertical angle theorem. The theorem says vertical angles are always congruent. So that means their measures are always exactly the same. So in this figure, that theorem is saying that angle 1 and angle 3 will always be congruent. And it's saying that angle 2 and angle 4 are congruent no matter what. In here, we're going to walk through the proof of the vertical angle theorem. So the reasoning why we can accept this statement is true. So the first step is that angle 1 and angle 2 form a linear pair. So the supplementary postulate there, or the supplement postulate, they are supplementary. That means that angle 1 and angle 2 add up to 180 degrees. It said right there. Now angles 2 and angle 3 are also supplementary. So their measures also add up to 180 degrees. So subtracting the measure of angle 2 from both sides of both equations, you're going to get the measure of angle 1 equals 180 degrees minus the measure of angle 2. And you're going to find that angle 3, the measure of angle 3 also equals 180 degrees minus the measure of angle 2. So by the transitive property, if the measure of angle 1 is equal to the same thing that the measure of angle 3 is equal to, therefore we can conclude that the measure of angle 1 is congruent to the measure of angle 3, those two vertical angles. And you could make the same argument in the same way for angles 4 and angle 2 being congruent as well. So that's how we know that the vertical angle theorem is true. Next, we're going to talk about what are called corresponding angles. These are angles that are situated in the same position but in two different locations. So for example, angle M is corresponding to angle M. Angle L is corresponding to angle L prime. Sorry, this is M prime, this is L prime. That's what we call a number that has a little apostrophe above it. You might have angle A, and related to it, you have angle A prime. That's just a math term. Don't be freaked out by it. Angle O is corresponding to angle O prime, and angle N is corresponding to angle N prime. All right, the first postulate we're going to talk about is what is called the corresponding angles postulate. This postulate states that when two parallel lines are cut by a transversal, that's this guy, line N, cutting through here. So that transversal is going to cut two parallel lines, line L and line M. Those lines are parallel. This transversal cuts those two lines the exact same way. So the resulting angles are going to be congruent as long as they are corresponding. So the resulting corresponding angles, in this case angle 1 and angle 2, are congruent. Now remember, a postulate is something that cannot be proven true. It's just one of those simple facts that is accepted to be true. The converse of this postulate is also true, that if two lines L and M are cut by a transversal in such a way that the corresponding angles formed are congruent, then we can use that fact to say that yes, those two lines are in fact parallel. So, because the original statement and the converse are both true, we can also write this as a biconditional statement. That's all for this lesson. Make sure you take some good notes. Come to Math Cafe if you have any extra questions, and make sure you come to live class as well, where we'll talk about this even more.